All right, and we're talking about a directed segment or a vector. We're simply talking about a movement from one place to another in the coordinate plane. That movement has two components. It has a y component, an up-down component, and it has an x component, a left-right component, meaning that if I travel from here to here, I both move someplace to the left in this case, and I also end up someplace further down. And to calculate what those are, we simply say I'm traveling from, make a little table here, traveling from 5, 3 to 3, 1. End minus start equals change. 5 minus 3 is negative 2. 1 minus 3 is negative 2, and it's a vector, so it ends up with the little brackets. Okay, or down here, we could say x, y. We're traveling from 1, negative 4 to 5, negative 1. End minus start equals change. 5 minus 1 is 4. Negative 1 minus negative 4 is a positive 3. So the vector 4, 3. We could do something more complicated where we have, instead of just actual coordinates, have some sort of an expression. This would be like, say, if I were tracking the vector from the point 2, 4 to some moving point. Right? We've seen things like this before with our parametric equations. Same thing though. X, y, from the point 2, 4 to 3 plus 6t, 5 minus t. So let's see, 3 plus 6t minus 2. Well, it's like a combining like terms thing. 3 minus 2 is 1. So it'll be 1 plus 6t. And I shouldn't extend my hair. And then 5 minus 4 is negative 1. So my vector is 1 plus 6t, or negative 1 minus t. Over here, same thing. I'm traveling from the point 2, 4 to the point 2 plus 3t, 4 minus 2t. Let's see, end minus start. 2 plus 3t, take away 2. We'll just 2's cancel each other out. End up with 3t, and 4 minus 2t minus 4. Well, the 4's cancel out and end up with 2t. There's our vector. And remember, it's always end minus start equals change. And that's how we can find vectors.